selection of n different things taken or at a time is called the combination. So there are 6 cross marks placed and the 3 boys can be seated in 6p3 ways. So NCR is also represented like this. The LCR is equal to n factorial divided by r into n minus r factorial. This is the formula which we are going to use to solve the problems. Hello dear students, welcome to this session of Discrete Mathematics class. I am Mr. Niranjan, Faculty Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence. In my previous class, we have discussed regarding the permutations. Now today I am going to take the second part, that is the combination. Now let us come to the combinations. Here in this session I am going to take the definition of combination and the problems based on the combination. Now combination is nothing but the selection. The selection is called a combination. Selection of n different things taken or at a time is called the combination. Now the different types of selections or combinations are the groups that can be formed from the given set of elements is called the combination. That is, the different groups or collection or selection from the given set of elements is called as the combination. So combination is nothing but the selection. The selection of n different objects taken or at a time is denoted as NCR. This is called the combination, NCR. So combination. So that is, if there are n objects out of which r objects are to be selected, then it is denoted as, it is given by n factorial divided by n minus r factorial. That's equal to NCR into r factorial. So therefore, NCR is equal to n factorial divided by r into n minus r factorial is called the combination of that is selection of n different things taken or at a time. So therefore, here the formula which we are going to use, that is the selection of n different things taking r at a time is given by NCR is equal to factorial n divided by factorial r into n minus r factorial. This is the formula we are going to use to find the combination of n different things taken or at a time. Now, suppose in particular case, if r is equal to n, if r and n are same, that is, if r is equal to n, then this becomes NCN. NCN is equal to n factorial divided by r is nothing but n factorial divided by n minus r is n factorial. Since n factorial divided by n into n minus n is 0, this n factorial gets cancelled. You know the factorial of 0 is always equal to 1. 1 by 1 is equal to 1. So what is the conclusion? NCN is always equal to 1. So NCN is always equal to 1. NCN is always equal to 1. Or for example, 4C4 is equal to 1. So NCN, the number of selection of n different things taking n at a time is nothing but 1. All at a time is equal to 1. So what is the formula we are going to use here? So NCR is also represented like this. The NCR is equal to n factorial divided by r into n minus r factorial. This is the formula which we are going to use to solve the problems. Now let us come to this first problem. If NC9 is equal to NC8, find NC8 and also find NC17. Also find NC17. Now what is given? NC9 is equal to NC8. NC9 is nothing but we know the formula for NCR. NCR is equal to n factorial divided by r into n minus r factorial. Here n is as it is, r is equal to 9. Here r is equal to 8. So here r is equal to 9. Put r is equal to 9. Here r is equal to 8. What you will get? N factorial divided by r is 9 factorial into n minus 9 factorial is equal to 8. N factorial divided by r is 8. N minus 8 factorial into 8 factorial. So this can also be, if you divide by n factorial and n minus 8 factorial and 8 factorial, what you are going to get on the left hand side? 1 by 9 is equal to 1 over n minus 8. Reciprocate it. 9 is also equal to n minus 8. Listen to me. So just cancel the terms which gets cancelled. Then 1 over 9 is equal to 1 over n minus 8, or reciprocate it. N minus 8 is equal to 9, or therefore n is equal to 9 plus 8, that's equal to 17. So here n is equal to 17. So if you substitute the value of n is equal to 17, what you will get? NC17, 17C17 is equal to 1, and NC8 can also be written as 7C8. That's it. Okay. So here to find the value of NC8, 17C8, and NC17 is nothing but 17C17. This is how we are going to solve this problem. Okay. Now let us come to the next problem. This very important problem. If NP3 is equal to 210, find N. Now just what is the formula for NP3? This NP3 is nothing but N factorial divided by N minus 3 factorial is equal to 210. This is permutation problem. So N factorial divided by N minus 3 factorial. Factorial of N can also be written as N into N minus 1, N minus 2, N minus 3 factorial divided by this N minus 3 factorial as it is equal to 210. N minus 3 factorial gets cancelled. What is left over is N into N minus 1 into N minus 2 is equal to 210. Okay. So if you want to just simplify this by simply multiply N minus 1 into N minus 2, you will get a quadratic equation. Again multiply with N, you will get a cubic equation. Solving that cubic equation, you will get the values of N. Or by inspection method, we can write the value of N is equal to 7. If you take N is equal to 7, now by inspection method, if you put N is equal to 7, what you will get? 7 into 7 minus 1 into 7 minus 2. What is this equal to? 7 into 6 into 5. So that is nothing but 5 6 are 30, 30 into 7, that is 210. So therefore the value of N is equal to 7. That's it. This is the easiest way to solve this problem, right? So just by inspection method, put the value of N is equal to 7. 7 into 7 minus 1 into 7 minus 2, 7 into 6 into 5, that is nothing but 210. So the value of N is equal to the value of N is equal to 7. That's it. Okay. Let's come to the next problem. That is again from combination. If NC4 is equal to NC5, find N. Very important and simple problem. Okay. Now just compare this. Comparing with NCR is equal to N is same, NCK. See here, NC4 is equal to NC5, comparing with NCR is equal to NCK. Okay. Then what happens? Then the value of R is equal to K, or R plus K is equal to N. See here, if we compare this, NCR is equal to NCK, R is equal to K, or R plus K is equal to N, right? Now here, since R is not equal to K, therefore N is equal to R plus K. Now what is R and what is K here? R is equal to 4 and K is equal to 5. This is R and 5. So in NC4 is equal to NC5, R is equal to 4 and K is equal to 5. So therefore N is equal to 4 plus 5, that's equal to 9. So therefore the value of N is equal to 9. That's it. Now listen to me here. Just by comparing with NCR is equal to NCK, the value of R is equal to K, or R plus K is equal to N. Since R is not equal to K, therefore N is equal to R plus K. Now from given expression, NC4 is equal to NC5, this is R and K, R is equal to 4 and K is equal to 5, therefore N is equal to 4 plus 5, that's 9, that's it. N is equal to 9 is the required answer. Now let us come to the next problem. If NPR is equal to 30, 24, NCR is equal to 1, 2, 6, find R. Here both combination as well as permutation both are given. NPR is equal to 3024 and NCR is equal to 126. Find the value of R, right? Now we know that there is one formula. We know that NPR divided by NCR is always equal to R factorial. Because what is the formula for NPR? NPR is nothing but N factorial divided by N minus R factorial, whole divided by NCR is factorial N divided by R into N minus R factorial. These two gets cancelled. 1 divided by R factorial, that is nothing but 1 by R factorial, that's equal to R factorial. So NPR divided by NCR is always equal to R factorial. Now what is given here? NPR is equal to 3024 and NCR is equal to 126 is equal to factorial R. Okay. If you divide 3024 by 126, you will get factorial of R. Now, so 3024 divided by 126 is nothing but 24. So R factorial is equal to 24. 24 can be written as 4 into 3 into 2 into 1. 2 3s are 6, 6 4s are 24. So therefore, the value of R is equal to 4. That's all. Because you know factorial of 4 is equal to 24. Here the value of R is equal to 4. That's it. Okay. Very simple. See here. We know that NPR by NCR is equal to R factorial. What is given? NPR is 3024, NCR is 126 is equal to factorial of R, that is 24 is equal to factorial R. What is the value of 24 in terms of factorial means? So 24 can also be written as 4 into 3 into 2 into 1, that's equal to factorial 4. So factorial 4 is equal to 24, therefore the required answer is 4, R is equal to 4, that's it. Now let us come to the next problem. If NC2 is equal to 36, find N. NC2 is equal to 36, find N. Listen to me. What is given? Given NC2 is equal to 36. What is the formula for NCR? N factorial divided by R factorial into N minus R factorial is equal to 36. So what is N here? N as it is, R is equal to 2 into factorial of N minus 2 is equal to 36. Now, what is this equal to? This is N factorial is nothing but N into N minus 1 into N minus 2 factorial divided by factorial 2 is 2 into factorial of N minus 2 as it is equal to 36. So, N minus 2 factorial N minus 2 gets cancelled. What is left over is N into N minus 1 divided by 2 is equal to 36. Cross multiply N into N minus 1 is equal to 36 into 2. Okay, simplify this, that's it. Now what is this equal to? N into N minus 1 is equal to 36 into 2 is equal to 6 2s are 12, 3 to 6 plus 1 is 72. Now just very simple, by inspection method put N is equal to 9. If you put N is equal to 9, what you will get? 9 into 9 minus 1, that is 9 into 8, that's equal to 72. So therefore the value of N is equal to 9, that's it, very simple. Okay, say if you want to verify, put N is equal to 9C2 is equal to 36, you will get. If you want, you can verify it. If you put N is equal to 9, what is 9C2? 9C2 is equal to factorial 9 divided by 2 factorial into 9 minus 2 factorial, that is factorial 9 divided by 2 factorial into 9 minus 2 is 7 factorial. This is 9 into 8 into factorial 7 divided by 2 into factorial 7, 7 gets cancelled. So what you will get? 2 4s are 9 into 4, 9 4s are 36. So you will get the value as 36, that's it. So therefore the value of N is equal to 9. This is how we are going to simplify. Okay, otherwise you can just multiply, you will get a quadratic equation, and simplify, you will get the value of N as 9, right? Now, let us come to the statement problems. Now, a committee of 3 persons is to be constituted. A committee of how many persons? 3 persons is to be constituted from the group of 5 men and 3 women. So, there are 5 men and 3 women. From which we have to constitute a 3 persons committee. In how many ways can this be done? How many of these committees would consist of 1 man and 2 women? So, see here, what is the solution? Here the order does not matter. So, therefore, we need to count the combinations. That means there will be as many as combinations as there are combinations of 5 different persons. There are 5 persons because 2 men plus 3 is equal to 5. So, 5 different persons taken 3 at a time. So, here 5 different persons taken 3 at a time is nothing but 5C3. The required combination is 5C3. 5 persons can be selected out of 3, that is in the form 5C3. What is the value of 5C3? 5 factorial divided by 3 into 5 minus 3 factorial. That's equal to 5 factorial divided by 3 factorial into 2. 5 factorial can also be written as 5 into 4 divided by into 3 factorial divided by 3 factorial into 2 into 1. These 2 gets cancelled. 5 into 4 divided by 2, 2 2's gets cancelled. 2 into 5, that's equal to 10. So 5 different persons taken 3 at a time can be constituted in 10 ways. So these are 10 ways. The first part, see here, there will be many committees as there are combinations of 5 different persons. So therefore 5 different persons can be taken 3 at a time. For 5 different persons taken 3 at a time, therefore the required combination is, number of ways is 5C3. 5C3 is equal to 10 ways. Similarly, the remaining part, now one man can be selected from 2 men. One man can be selected from 2 is 2C1. So 2C1 ways, and again 2 women can be selected. 2 women can be selected out of 3 women in 3C2 ways. So 1 man out of 2 men and 2 women out of 3 women can be selected in 2C1 and 3C2 ways. So therefore the required number of committees are 2C1 into 3C2. So 2C1, the value of 2C1 is equal to 2, and 3C2 is nothing but 3. That's it. So here this is equal to 2 into 3, that's equal to 6. That's it. See, so 1 man can be selected out of 2 in 2C1 ways, and 2 women selected from 3 is 3C2 ways. The required number of committees is 2C1 is 2 and 3C2 is equal to 3. 2 into 3 is equal to 6. The required number of committees which can be selected from 2 men and 3 women is 6. That's it. Okay. Now, hope you followed. Let us come to the next problem. Similar type problem. Problem 2. In how many ways can 5 girls and 3 boys can be selected in a row so that no boys are together? So here, in how many ways, how many girls? 5 girls and 3 boys are to be selected in a row such that no 2 boys are together. Here, let us come to the solution. Let us first arrange the 5 girls. This can be done in 5 factorial ways. For each arrangement, there are 3 boys can be seated only at the cross mark like this. See, a boy, girl, boy, girl, boy, girl, boy, girl, boy, girl, and boy, girl. So 5 girls, this can be done in 5 factorial ways, and the 3 boys can be seated at the cross marks like this. So therefore, there are how many cross marks are there? 1, 2, 3, 4, 5, and 6. So there are 6 cross marks placed at the 3 boys. So therefore the 3 boys can be seated in 6p3 ways. 6p3 ways. Hence, by the multiplicative principle, there we have the number of ways is 5 factorial into 6p3, that is equal to 5 factorial into 6p3 is nothing but 6 factorial divided by 3 factorial. So that's equal to 4 into 5 into 2 into 3. So that is totally equal to 14,400. So this is the required answer. So therefore 3 girls and 3 boys can be seated in a row so that no boys together is arranged in 14,400 times. That's it. Okay. Hope you followed. Right. Here 5 girls and 3 boys can be seated in a row so that 2 boys are together. So the boys can be arranged in cross marks like this. So there are 6 cross marks placed, and the 3 boys can be seated in 6p3 ways. 6, 1, 2, 3, 4, 5, 6 cross marks are there. So how many boys are there? 3 boys are there. So they can be seated in 6p3 ways. Hence, by the multiplicative principle, the total number of ways is 5 factorial. So because there are 5 girls, 5 factorials into 6p3, that's equal to 5 factorial into 6p3 is nothing but 5 factorial into 6p3 is factorial 6 divided by 6 minus 3 factorial, that's equal to factorial 5 into factorial 6 divided by 6 minus 3 is nothing but 3 factorial. This is factorial 5 means 5 into 4 into 3 into 2 into 1. into factorial 3 and 3 gets cancelled. We will have 6 into 5 into 4. So that's it. So that is 4 into 5 into 2, 5 into 4 into 2 into again 4 into 5. So this is totally equal to 14400 ways. That's it. This is the second part of the problem. Okay, that's it. Now hope you followed. So these are few simple problems based on permutations as well as the combination. Right. That's all regarding today's session. Let us meet with a different type of concept in the next session. Thank you. Thank you very much.